It's my pleasure to introduce Mark Moran, who is a school-based technology specialist at Island Creek Elementary School in Fairfax County, and to the rest of the state, that's an ITRT, just so you know what's going on here. And Mark has been using Scratch with his students for quite a few years. Mark, how many years have you been working with the kids in Scratch? At least 3 or 4.
Pretty much since it came out. I remember when I first started in SFITS, which I think was about 7 years ago now, Tim shared it at one of our meetings, and I've been hooked ever since, started fiddling around with it. It's definitely my favorite program at the elementary level.
7 years. Time flies, doesn't it? Okay.
Sure does.
Well, I'm going to turn this over to you, and he's going to show you some of the things that his students have done and some of the sample projects he's been using and how they're using it to teach other things other than programming. Go right ahead.
Okay. And I apologize if my voice doesn't sound real clear. I'm fighting a bit of a cold, but I'll do the best I can here and hopefully be able to understand me okay. Yeah, Scratch is just terrific, and I understand there's some more advanced programming softwares that folks at the middle school and high school levels use, but for elementary kids, I think it's just perfect. And to be honest, I don't even really think of it as a programming software, at least not primarily. I tend to think of it more as animation, and I think it really lends itself to taking content and concepts that kids are learning, especially some of the things that are a little more abstract, and by letting kids manipulate on the screen, they really, it becomes a little more concrete, and we really can emphasize those 4 C's, and again, I don't even think. I think of the programming aspect sort of secondarily. I mean, there's great logic involved, and there's a lot of hidden math there, which is all wonderful, sort of sneak it in on the kids. But I tend to look at curriculum first, and what it is the kids are supposed to be learning, and then thinking about what programs can support those concepts. And I find very often I keep coming back to Scratch because it's so flexible. So I thought what I'd do is just share a whole lot of samples, some kid samples and some demos I've made to approach a lot of different grade levels at the elementary level and different types of curriculum, and to show how versatile the Scratch program is. So I'm going to go ahead and start with the first Scratch lesson I ever did, which was actually with 2nd grade. And 2nd is about as low as I've gone with it. I think with a lot of teacher direction we could go lower, but the kids can definitely do quite a bit at 2nd grade. So I'm going to see about the sharing here. I got a file open, and let's see. Scratch isn't showing up here. Hold on a second.
Yeah, make sure you have the program open first before you try to start sharing it.
Scratch is still open, and I got spinning right now, Tim. It says select start sharing. Oh, there it goes.
We'll try it again.
Let's try again.
And click the start sharing button.
I did, but it's when I get the list, it's not showing Scratch even though it's open. Why don't I close Scratch and reopen it?
Try closing it and reopening it. Sorry for the technical issues, people.
Yep. It worked a minute ago, I promise.
It always works in rehearsal. That's my motto. While Mark is trying to get that going, one thing that I've noticed about kids using Scratch is it really helps improve their understanding of the coordinate plane. Because in order to get things to move around the Scratch screen, you have to understand that positive and negative coordinates, which I think is one of the toughest things that some of the kids have to understand later on in math.
Are you guys seeing it now?
We're good.
Okay. And for those of you unfamiliar with Scratch, this is how it shows up. It's really sort of that blank slate software. It comes up with a blank canvas, and we always get rid of the cat. But I'm going to go ahead and open some files from here. And the first demo I'm going to show you here, as I said, was a second grade lesson, and they were studying biomes. And the Sonoran Desert was one of the biomes they've been studying. They've been studying different animals and learning animal adaptations to the desert and that kind of thing. So brace yourself for some sort of obnoxious animal noises here, and it's going to open. And we'll start the animation, which you do by clicking the green flag here.
I don't think they'll hear the sound, so we'll just do the animation.
Oh, okay. But there's that fox, that gray fox, is barking, and there's a toad trilling, and lots of sound. So it's very multimedia. And this is a demo I showed second graders with a lot of the different animals they've been learning about in the Sonoran Desert. And so that was the demo that I made to show them, and I'm going to show you a student sample now so you can see what they came up with. But basically what we did, we had a series of backgrounds they could choose from. We kept these on a server folder that they could access, and also the different animals. And in Scratch, they had its own lingo. The little characters that you bring in and animate, they call sprites. So, and you can create your own sprites quite easily using basic photo editing software. If you're familiar with the magic lasso that a lot of programs have, like Pixie or Photoshop, Image Blender, things like that, and then you can cut out the parts of an image you want and save it as a transparency and bring it in to Scratch and animate it. So we let each second grader choose their background. We let them pick one animal to begin with as they begin to learn the program. The way I approach it in almost any Scratch lesson is I show them a few, if it's their first time with Scratch, a few very basic movements, and then I let them go and let them explore. They have some direction, which is obviously to, in this case, try and realistically make their animal move in its environment that they've learned about. And they explore, and they do a lot of trial and error, and they do a lot of stealing of ideas. And I think, I mentioned the 4 C's earlier, but I think the communicating and collaborating aspects are often overlooked with Scratch. I think kids are really good at borrowing ideas from each other, and I encourage that, and so they learn a lot quicker that way. And for those of you who are just learning about Scratch, the way you animate is you select your sprite once you've imported a picture, and you build a script for it in this middle area right here. And you build your script by borrowing pieces from these various menus over here. So I'm in the control section, and I can pull this when the green flag piece over. You just drag them into your area, and that'll be the trigger piece, so that when you click the green flag over your stage here, it will make all the rest of the bits of your script that you put together operate. And this is the programming. But really it starts with the kid saying, I want my hawk to fly across the screen. So they figure out what's going to be their starting point, and they use one of these blue go-tos, and this is where that coordinate plane that Tim was mentioning comes in. And there's negative integers here, and I'm teaching this to second graders, and I'm not turning it into a math lesson. They're not going to learn, really plotting on a graph, until about 4th grade. But what they can grasp is that as they move the cursor across the stage, if you see this XY below the stage, it's showing you where it is on the plane. And the kids, we're not talking integers, they just know that, hey, if I want this animal to go to that spot, then I got to put this number excuse me, in the X box, and I got to put this number in the Y. And they learn to watch for that minus sign, as they call it, in 2nd grade, and they're just copying numbers. But I think it'll certainly help them when they do get to learning a little more of graphing and that kind of thing, that they have some background playing around in Scratch. So they learn to do these pieces, and it's fairly intuitive. So as you look at the labels on these pieces, go to this X and Y, point in that direction, glide over here, hide, some of these different pieces, wait 1 second. The kids pick it up pretty quick, and I start just by showing them the basic movements, and then they explore other pieces and start sharing with each other and go from there. So from that original demo that I showed them, this is a young man named Corey, and I just clicked the green flag, and he all by himself figured out how to make that hawk swoop down and eat the tarantula. In fact, this kid had showed me how the hide piece works. Up to that point, I had never touched it, didn't know it existed. He was exploring on his own, and I think that's pretty amazing. A second grader would just go in and fiddle around and then apply his logic to make that work. And he figured out all the timing to make the hawk come down at just the right moment, and that tarantula had to be there just that moment and give the illusion of an animal, in a predator-prey relationship. So, these kids had learned this already as far as researching animals, and now they're applying this abstract concept of how an animal interacts in its environment, how it adapts, and animating it and making it a lot more real. And I think that's what Scratch is all about. So I'll show you some more samples. I'll jump all the way up to 6th grade. And I hope everyone's hearing me okay. Let's see, let's do exploration.
Mark, in the chat room, Kim is asking, how long did that particular project take, that last one with the hawk and everything?
They learned basic movements and getting animals moving back and forth, turning, stopping, that kind of thing, pretty much in their first session. Bringing in their pictures. We limited, and they were only allowed to choose one background and one animal to be the sprite initially. The teacher, the first teacher I did this with, she didn't do a whole lot in the computer lab at the time. So she sort of fell in love with this because the kids could just sort of self-operate there, and so she kept bringing them back and back and back. I think she had them working on it for about 5 consecutive class periods, but it didn't need to be that long.
A class period is about what, about an hour?
On here, so about 45 minutes at our school. I'll show you a 6th grade one we did. This was solar system. And our 6th grade astronomy unit, they study the solar system, and they have to study, a lot of the SOLs involve relationships of planets to the sun, the order of the sun, rotation, revolution, comparing planet sizes relative to one another, particularly to the Earth, distance from the sun, a whole slew of concepts. So I was trying to think of a way to make learning all that fun, and I didn't want to have to do, separate Scratch lessons for all these. So what we did, we came up with its teacher. We came up with a list of challenges, 7 different challenges that we had on one sheet we gave to the kids, and then we made one template that would go with all the challenges. And all the template is, as you can see, we brought in sprites for each of the planets. And they're all just lined up in no particular order down here at the bottom. And so we gave them a little, printed sheet, Word doc. It just said challenge 1, challenge 2, and it described each challenge for them. One was very simple: put the planets in the correct order from the sun. Another one was try to, it's impossible to do a perfect scale, of course, but try to, as best you can, to size the planets relative to one another. And obviously you need to exclude the sun because that would totally set off the scale. But what the kids would do, and we wouldn't tell them anything. We wouldn't show them how to do anything. And really most of these kids, had almost no exposure to Scratch, if any at all. And they just figure things out, as kids will do if you leave them alone. And they would figure out, the one thing we did do, we gave them a link to the NASA Kids site so they could do a little research. And that's a really nice site to go with this because it gives basic information on like volume, size, distance from the sun. So they could find that information on their own. And then they would say, well, I need to make Jupiter really big because that's, however, I don't remember exactly, but however many times it is the Earth size, that's the largest planet. And they would figure out, oh, there's a grow tool at the top. And I can click on this, and I would not show them this. They would figure it out, and then once one kid got it, another kid would say, oh, how'd you do that? And next thing you know, there's 10 kids behind one kid watching how he does it, and they're all running back to their seats and doing it for themselves. And that's much better, as far as I'm concerned, of how things should work, rather than me telling them. And once they figure out that Jupiter needs to be really large, then they go and they, figure out, well, what fraction of that size should the Earth be? And they go and they start to size their planets. And they do that with all of them, and then they get, obviously not a perfect scale, but they get a much better understanding of planets and their relative size to each other. So, like I said, I think there were about 7 different challenges. Another one was see if you can make your planets revolve around the sun. Let's take it a step further, see if you can make them revolve around the sun in order. And they can't have them be the relative sizes and rotate, or obviously all we'd see is Jupiter spinning around. So they would use the template and start over for each, the same template, using it to start over each challenge. So I'll open one student sample here, and this one was challenge 5 complete. I think this one was making all the planets revolve around the sun and be in the correct order, which is one of the little more higher level challenges. So I animate it. He did it, and he did it on his own, and he figured it out with some very basic pieces. And if you look over here at his script, he's got to move 10 steps, which is like little small increments, and then turn a certain number of degrees, and then he put them in a forever piece, which makes it repeat. And he just explored. There's a lot of trial and error, and he figured it out. And when you stop this, you'll see there's Mercury is the closest, and then Venus and Earth and so on. I don't think it's absolutely perfect, but he got it pretty much. And so what I like about doing that type of activity is, again, you're sort of getting out of the kids' way, letting them explore, letting them do that critical thinking, collaborate and talk with each other, borrow each other's ideas. One kid would see how another kid did something, go back and then approve upon it, and it's just a very rich environment, I think, when you have kids going back and sharing ideas and that kind of thing. So so these are a couple of science lessons so far, and just to show how versatile Scratch can be, I'll jump the language arts here real quick. This was a demo for animating poems, haikus specifically. So to have the kids write a haiku, and then sort of to add a little more oomph to the poem and their words, do a little animation. So animate this one. I'll try and go full screen this time. See if that works. Okay, so that was just sort of short and simple. Haiku is a short poem, but what I like about this one is, getting the language arts in there and doing something different with words. It's what, again, the beauty of Scratch. This is not something you can do on paper. It's great when kids act things out and that kind of thing, but to be able to do some animation and make words do what you want. The kids that did these were very excited about it. They had a lot of fun, you know, playing with words and language in different ways,
Mark,
and entertaining each other.
Mark, Kim wants to know what grade level that was, the haiku project.
This was 5th grade, but I think you could do it with a lot of different grade levels. I forget what I was going to say. But as far as animating the words, we use Pixie. I don't know if every school system watching today has access to Pixie, but in Fairfax County, it's, you know, we have it in all our elementary schools. So it's much the same as making a picture sprite or character. You can go to Pixie and make a word look a certain way, and then export it as a picture file and bring it in, and then move it around, animate it. And you'll see the script over here. Again, it's very simple steps. This is not heavy-duty programming. Again, I sort of think of the programming as an afterthought. It just comes naturally. And they can do complex things with it, again, if they have more time. But I think the best thing is just let them have fun with what they're learning. So let's see what else we can look at. I'll do another. Oh, here's the Explore one I was going to show you. This was a 6th grade one. And this is, you know, a lot of my motivation for doing lessons with Scratch is I think of, you know, the old ways we learned things, the way I learned things, and how boring it was, and especially textbooks. You know, like Explorers, you know, if you learned where Champlain explored, they're showing you some boring, you know, cartoony map in a textbook with an arrow drawn on showing where he goes, you know. And Scratch, in a very short amount of time and very simply, can really give that a boost and make that concept more concrete. So I don't know if you're hearing the child's voice here. I think Tim said the sound won't carry over from the program. But the student right now is narrating about Samuel de Champlain. So the ship is actually, we made this sprite from a real image off the web of, I think, a painting of Champlain, and we cut it out and made the sprite. But the ship is actually traveling the path that Champlain, he probably didn't do that whole thing in that ship, but it's showing an animation where Champlain explored, and the child's voice will narrate. So the audio is, you can't hear it, but the kid is saying who Champlain is, where exactly he's explored, saying, you know, down the St. Lawrence River, and all the rest of it. And it's pretty short and sweet. And at 6th grade, you know, the SOL, I think there's 4 explorers they have to know. There's Coronado and LaSalle and Cabot, and so kids got to choose which explorer they wanted to do, and they got to animate that path and share them with each other. So they had fun with that. And let's see, the 3rd grade one. This was a demo I'd made for Rock Cycle, and I thought I had a teacher on the hook for this one, but we never quite got there. I'll try again this year. This is an example, I think, of where you can take a pretty abstract concept, and you're trying to teach 3rd graders how rocks go through their cycle, changing from igneous to sedimentary to metamorphic, and how it's actually a cycle and it continues. So the drawing capability in Scratch is pretty good. It's not as good as Pixie and some other programs, but there is a drawing palette, so you don't even have to bring in pictures for sprites. You can draw backgrounds and things on your own. But I'll animate this one and talk over it. But basically you see we found a picture of an igneous rock from the web and cut it out and brought it as a sprite, and it comes down, it gets weathered by the rain cloud, and goes in the sea, and then gets pressured, and under pressure changes to a sedimentary. You saw it just change, and then moves on to metamorphic, and then changes to igneous and back. So using some of the effects in Scratch, and then it just goes on and on. We have these forever pieces, which are perfect for cycles. So you could do this with water cycle, you could do it with pretty much any kind of cycle, and it just goes on and perpetuates. And the idea is to have kids narrate this and explain how the cycle works and prove that they understand it.
Mark, I really hate to cut this off, but we are actually at the end of our time. We may rope you into doing a Scratch session for one of our VSTE webinars sometime and go into more detail about how this works. But are there any other questions? Any final questions for Mark? On the screen there's a link for the Scratch website, which they have an amazing number of activities and programs that people have uploaded, and you may want to go there to see some other samples. And then there's a link to Mark's Scratch page on his school website, and a lot of the samples are up there, right?
Yeah, there's about 8 or so samples, a couple of the ones I shared tonight and some other ones. And the great thing is when those are links to the Scratch website where those files are mounted and posted, and you can download. You can watch the animation. You can also download the file itself. And there's a lot other kids in schools and people are posting their files there, and they're great because you can download them and then you can deconstruct and see how people did things, how they made animations happen, and learn a lot that way.
Thank you very much for doing this. I know you've got the same kind of cold that I do, I'm sure. My voice is going too. But, thank you very much. And if you have other questions for Mark, we can collect them together and send them to you. Okay?
It's my pleasure. I'll type my email in the little chat there if anyone wants to contact me.
Great. And okay, we'll take a couple of minutes break here while we shift, and then we'll come back and do the final block of the evening here. So stretch a little bit, and I'm going to go find a Kleenex.